Good afternoon, you guys. Glad you could make it. You're back from lunch. Enjoy your lunch. It was good, right? Okay, most of you saying yes. Good deal. All right, so today we're talking about the Industry 4.0 trends that matter, as opposed to the ones that don't matter. I don't know, maybe then you'd ask, why is it a trend? So I'm not even going to go down that road. So we're going to talk about the industry trends that matter today. So a little bit about me. My name is Jerry Foster. I'm the CTO at Plex Systems, and we make manufacturing software. I've been married for 28 years, got 4 kids. You might be able to tell by the picture, we keep the local optometrist in business. I think we're his only clients. Sometimes our glasses bill is more than our grocery bill. I love to play racquetball. In fact, I just got back a few days ago from the US Open National Racquetball Championships, and you didn't even know there was a US Open for racquetball, did you? I love riding my big green Monster Vulcan motorcycle and really enjoy that. You know, 29 years ago, next week, I started as a programmer at a forging company. You can't tell right there, I have a full head of hair. That's why I love this picture. I just keep it on my desk and reminisce about those days. So I started as a programmer at a forging company, and that was where I cut my teeth on manufacturing. And I've been in manufacturing ever since. I remember coming home from this job, and my wife would be like, you got grease on your shoes and you got oil and graphite all over you. What are you going out there and wallowing in the plant? And I'm like, I don't know. It's just fun to be out there, right? So I've implemented dozens and dozens of systems at manufacturers. I've been exposed to hundreds of manufacturers as they have worked on and implemented and utilized technology. So a lot of my talk today is going to come from my background in manufacturing. So, and that's the lens that I view things. But I think most of what we talk about today will apply to you no matter what industry you're in or where you're at right now. So we're here to talk about Industry 4.0 trends. And I was thinking, yeah, another talk on Industry 4.0. Like, are you guys tired of Industry, talking about it? And I'm like, well, but yet here you are. Apparently not. So we're going to talk about it some more. You know, I sense many of us having this feeling of maybe being saturated with all this talk, but at the same time having this sense inside of us that we need to be doing more. We need to be connecting. We need to be working on all this Industry 4.0 stuff. How do we do that? How do we get started down that path? So that's what I hope we can help with, and I can help with over the course of the next 45 minutes or so. So, if you remember your textbook from junior high, you probably saw this picture, right? The 3 industrial revolutions. Of course, the first industrial revolution in the 1800s when we went from producing things by hand manually to actually using machines, specifically a steam machine. And then, of course, the second industrial revolution where there was rapid industrialization with rail and telegraph and electricity culminating in the production line. And then the computerization, then the third revolution. Computerization, automation, and automating all of those processes that we'd already put in place. But now all those textbooks are going to have to be rewritten, right? Because now we have a 4th industrial revolution. In fact, you'll probably hear me talk about it as connected manufacturing. That's kind of how I couch that, the industrial revolution. A lot of people call it cyber-physical, but to me it's just connecting people, machines, and products to algorithms, software, and technologies. It's really about dealing with virtual representations of physical things. Do you guys remember the first time you saw a virtual representation of something physical? I remember what it was. It was 1976. Do you remember what that was? Anyone? Star Wars, right? Princess Leia came out on that hologram, and I was like, oh man, that's awesome. And Luke Skywalker was like, oh, she's beautiful. I'm like, oh, that's awesome technology. That was just like so cool. This is a virtual representation of something physical. But that's where we're at right now, right? We're like in Star Wars right now because that's what we're dealing with. Virtual representations of things that are physical. And then if you think about it, next year is 2020, right? I can finally say my family can all see 2020. But okay. But next year is 2020. It feels like that's the future, 2020, right? I remember when I was a kid, I was watching Space 1999, and I thought, if I get to 1999, it's going to be so freaky because that'll be the future. And we're 20 years past that. And we don't have spaceships, but we do have smart toilets. So, I don't know, that might be a good trade-off there. In fact, while I was researching this has nothing to do with anything, but I came across this headline. It says, Kohler launched a smart toilet with Alexa inside. I'm like, did she sign up for that? And then I thought it had to be a joke, but it wasn't. There was no tongue-in-cheek. It was just a straight article. I'm like, oh my goodness. All right. But I don't think you came here to talk about toilets. The point is we're in the future now. Cool stuff is happening right now. And so let's take that back and talk about Industry 4.0. Industry 4.0 is really the part of the 4th industrial revolution that pertains to just industry, right? What does that mean? It means it deals with those of us who make stuff. We make parts, we build parts, we make things. It's tangible. And that's what I love. That's what I love about manufacturing, that tangible thing, right? It's for businesses that do that. But why should you care? Why should you care about all of this, all these buzzwords and these acronyms like IoT and RPA and AR and VR and XYZ and PDQ? Why should you care about all of those acronyms, right? When I think of that question, why should I care? Why is this important to me? I think of actually a person, and his name is Richard McDermott. Richard was the president and CEO of the forging company that I started at about 29 years ago. And he was a self-made man. He was an immigrant who came over from Europe. And he was incredible. What he would do, he would buy these abandoned, desolate plants in downtown Detroit that people had for pennies on the dollar. And then using his sheer force of will and an incredible mechanical mind, he would rebuild those presses and those machines and get them working again and actually start building parts. And he had just a fanatical following from his employees. And so our little computer department was doing some really cool work for Richard and one of his forging companies. We were building an MES system. We were connecting tooling. We were connecting CNC machines. And Richard came to me one day, and he had a serious look on his face. And I thought for sure he was going to say, Jerry, thanks for being such an incredible programmer. Your expertise is unparalleled amongst all the legions of developers the world over. But he didn't say that. We were working on a press, and he actually looked at me and he said, Jerry, I don't care what you do, but you better not bring that press down. If it's not going up and down, we're not making parts. We'll go out of business. I was like, okay. Don't bring that press down. It's got to be going up and down. And then it hit me when I reflected on that the reason we keep talking about Industry 4.0, the reason it's important is not about all these technologies. It's about Richard. It's so we can help Richard make parts better. That's why we keep talking about it. That's why we're doing what we're doing. And that's why it's exciting. So, I would say to Richard now, instead of worrying about that what we're doing is going to cause downtime, we can actually take these technologies and now start to predict downtime or analyze why that downtime might happen and hopefully prevent that downtime from happening. That's the beauty of what the technologies we have at play with us for Industry 4.0. So what are these technologies that can help Richard? When people think of Industry 4.0, we're usually talking about anywhere from 10 to 15 different technologies, depending on who you talk to. But in order to talk about them holistically, we've kind of wrapped them in this term called Industry 4.0. It's like this big name, Industry 4.0, and it kind of can seem overwhelming, right? When you look at all these technologies, you might feel overwhelmed, and you're like, Industry 4.0, I just installed Industry 2.3. We're like way behind. How do I get to Industry 4.0? So it can seem a bit overwhelming when you look at all those technologies. But here's the thing. Most of these technologies have been around for a long time. They didn't just pop out of the blue. It's more of a continuum than a big bang. And that starts to give us hope on how we can approach getting on board to Industry 4.0. You might be saying, you know what, I can identify with that. In fact, some of you might even recall a time when you were working on a mainframe in college with a central computer that would divvy up compute power as you wrote programs in Fortran. That's you, you're really old, right? Yeah, I'm sorry, sir. Yeah, she's like, I did that, right? But that's the case. This is an IBM 709. This was delivered to MIT in the mid-'60s, and its purpose was to be a centralized computer, powerful computer that would divvy up compute time to all the students. It's a precursor of the cloud, 60 years ago, all right? And then big data. Big data we didn't just go from kilobytes to petabytes overnight. It was gradual, more and more data, more and more data, more. And then somewhere along the line, someone's like, well, there is some big data. And then we said, okay, big data, right? But it's coming for a long time. It's not anything new. So that begs the question, if these technologies have been around for a while, what's so special now? Why do we talk about them now as this great big revolution? What's the big deal now? And in my opinion, the reason it's a big thing now is because of the convergence of cloud, data, and compute. It's those three things coming together that has allowed us to take these technologies that have been around for a long time and use them exponentially, use them in ways that we had never been able to before. We now have a platform, the cloud, on which we can store a ton of data cheaply and then apply to it almost unlimited computing power, something we've never had in the past. And the cool thing about this right here is it levels the playing field. All right? It makes it available. It democratizes all of these technologies and puts them in the hands of everyone at a scale that fits them. These are no longer just available for rich companies that can afford it. Anyone can afford this, just about anyone, even down to mom and pop shops. You can get on board with these technologies because of the cloud, and because of the technologies we have available to us. And you can start mixing and matching these technologies and using just the ones you want, and usually end up with a system that's more than just the sum of its parts. But I think that's why companies struggle a little bit with Industry 4.0, because it's kind of nebulous, right? There isn't a really strong definition. It's kind of gray. Here's all these technologies, and we've slapped a name on it. Okay, have fun. And we're like, I'm a manufacturer. I want control. I want an upper and lower control spec, and I want an X bar and R chart, and I want to know I'm inside Industry 4.0 tolerance, right? That makes me feel good. But there isn't anything like that. So it's up to us to navigate these technologies and figure out, how can I apply them to the business that I'm in? And that's how I would suggest you start thinking about this. Take a look at it's kind of skewed there, but I would actually start at your operations, at your plant, at your company. What is it that you do? What do you make? What processes do you have in place? And how do they work? And then your 4.0 decisions are more like an on-ramp. How do I merge the physical that we're already doing with some of these with some of these technologies that we've already looked at? How do I merge them? And then it's an easier thought process. It's like I'm stepping onto an on-ramp. Here's the physical that we're already working on, and here's a couple technologies, and I'm going to start merging them and using them. Instead of just like jumping off this cliff into this great big Industry 4.0 void, all right? So I always recommend start with the end in mind. Start with the business that you're looking at or that you work at. So I want to divide the rest of my talk kind of into two sections. The first one is 3 tips that can help you get started on your Industry 4.0 journey, and then 3 technologies that I feel are really poised to disrupt the industry going forward. So let's start with those 3 tips. The first one is this. Think in terms of business value. Have you ever come across an article that says you need an IoT strategy? You need an IoT strategy right now, and you're like, oh my gosh, I need to know. I don't have an IoT strategy. Do you have an IoT strategy? I don't have an IoT strategy. And I'm behind. I don't have an IoT strategy. But your job is not to implement an IoT strategy. Your job is not primarily to implement technology. Your job is to make your business profitable. Your job is to reduce defects in your parts. Your job is to increase the safety of your employees. Your job is to improve efficiencies. And technology is the tool to help you do those things, right? Technology is not the end game. A lot of people are like, oh, it's all about the journey. And sometimes it is, but not in business. It's not about the journey. It's about the ROI at the end. It's all about that. And so we have to think in terms of these value drivers. This is a chart from McKinsey, and what they did is they went and interviewed a large number of companies that had actually done some Industry 4.0 work. And then they brought those metrics back and put them in place for these value drivers. And you might not be able to see this in the back, and there will be a recording that you can get this. But they have 8 value drivers here, like labor and inventory and design, assets, et cetera. And then they applied some of these metrics to that value driver. Just as an example, we have an automotive industry player here. For time to market value driver, they shaved 2 months off their product introduction by using 3D printing, right? We've got a mining company. They used autonomous vehicles, and they reduced their fleet costs by 10% when it comes to labor. And so this is how you start thinking about and articulating the work that you want to do in Industry 4.0. It's in this context, these value drivers. And this will do 2 things for you. The first one is it will keep you from that occupational hazard that we all have, especially if you're kind of a technology person, of wanting to introduce technology just for technology's sake. Last night, I got home from work, and what do you think was sitting on my porch? A box from Amazon, right? Yes, and I opened it. You know what it was? It was brand new Bluetooth earbuds. I have a confession to make. I really didn't need new Bluetooth earbuds. They were just cool. That was new technology, and I didn't have one, so I dropped $50 that I probably shouldn't have on Bluetooth earbuds. But that's something that we all have a tendency to do because we like new, shiny things with technology. But that's not necessarily what your business needs you to do. It needs you to think first in terms of this. So that's the first thing it helps you to do, is avoid that occupational hazard. The second thing is you have a much better chance of having your initiatives accepted and approved and given budget if you can think of in terms of what is the business value, what's the driver that I'm helping our company achieve. You don't want to run into your CEO's office and say, hey man, we need to connect some machines and add some sensors and put it on OPC network, and he says, why? And you're like, because it's really cool. What do you mean why? No, you need to say something like, you know what, boss, I did some research, and for companies that are in our industry, when they implement an IoT solution, they improve efficiencies on average by about 15%. And I'd like to do a proof of concept with just 2 machines and see what we can get out of that. So that's how you start thinking, start articulating your work in terms of the business value instead of the technology, because that's your job. Second tip, start with an already well-defined process. See, advanced technologies can really accelerate the transformation, but if you try to apply that, especially when you're first starting out, if you try to apply that to a process that's already broken, you're probably not going to get the ROI you expected, and then you're not going to know why. Because did the technology fail? Did it not integrate well with that process? Or is it a result of the process being broken? And so you're going to spend all these cycles trying to figure out what was the problem, only to have it probably end up being the process and not the technology. If you'll forgive me, I'm going to take off my, it's all that's coming off, this jacket. It's getting warm up here. Now, as your strategy picks up steam and you have some wins, then you can start going back and saying, how can I use this as a catalyst to fix some of these broken processes? But it's always key to make sure, especially when you start, that doesn't have to be a perfect process because then there would be no room for improvement, but it shouldn't be broken. Third tip. Remember the people. Don't forget the people. There's always people involved in any introduction of new technology. There's always people involved. Deloitte said recently that in the coming years, almost all work, no matter what you're doing, almost all work will involve technology or robots that we aren't working with right now. That's kind of amazing when you think of it. It means all of our jobs are changing. And so when we want to implement new technology, we need to make sure we are doing it in a way that is acceptable to the people who are going to be affected by it. Because no one likes change just foisted on them. They don't like it. It makes them feel small. It makes them feel unimportant. And then they'll respond negatively, either overtly or covertly. They'll either be apathetic or they might try to actually sabotage what you're trying to do because you didn't include them. And it's up your job, it's your job when this happens or when you want to introduce technology to communicate and to communicate some more and then get feedback and take that feedback seriously. Involve your employees in every step of the way. And it's hard. This is hard for someone like me, okay? I'm an introvert. I'm an engineer, and just to be honest, if all of us were at a party tonight, don't be offended, but I probably wouldn't come up and introduce myself to you, because I'm a nerd and you all scare the crap out of me, okay? That's just who I am. I've gotten a little better over the years, but I'm an introvert. I remember at one company that I was at, we were implementing a new system, and they were moving from one of those, just a green screen terminal type system to a brand new Windows GUI really cool Windows Form-based system, right? And of course, it's so much better. And I remember the boss telling me, okay, you need to go down onto the shop floor, and you talk to the foreman and help them use this new system. And I was like, do I have to go talk to people? You have to go down and help them? And he's like, yes, go down there and help them, all right? So I went down there, and first person I saw was Chet, the foreman, big Chet. And he was struggling to use the new system, right? And so I said, okay, Chet, what's going on? How can I help you? And he said, well, I'm struggling here. I want to add a maintenance record. And I'm like, oh, that's easy. You just press this button right here. So he went to the keyboard and tried to manipulate the keyboard in the same way that he would have with his old system to get to that button. And I said, no, you just use the mouse. And he picked up the mouse and he put it on the monitor and tried to press the button. I was like, oh my gosh, we missed a step. We missed a step. You can't just foist technology. Because we're technology people, we just assume it's going to work. And we assume that people are going to love it. But you have to include them. It's our job as leaders to have our feet planted in both worlds, the technology and the people. We don't have the luxury of just sticking to the technology, all right? So those are the 3 tips. Think in terms of business value, apply tech to well-defined processes, and whatever you do, don't forget the people. Excuse me. Now, the abstract said we were going to be talking about which revolution-related tech trends you should be paying attention to. The truth is you should be paying attention to all of them, because they all have potential in your process, in your factory, in your business. They all have potential, so we need to be paying attention to all of them. But I've only got 20, 25 minutes left, so we don't have time to talk about all 10, 13, 15 of them. So I thought what I'd do is, just kind of, just from my experience the last couple of years and looking ahead at what our customers are doing and the research that I've been doing, just kind of talk about maybe 3 technologies that I think are really poised to really disrupt manufacturing, Industry 4.0, the Industrial Revolution, all right? And they all are at different stages in their life cycle, but these are all technologies that I think are really, really important. The first one is artificial intelligence. Now, what do we mean by artificial intelligence? That word artificial, we often associate that with the word fake, right? So you might be thinking with your kids, like, you ever had that thought, like, what are you doing? I don't know if you can see that some guy sitting on the back of a crotch rocket. What are you thinking? You ever said that to your kids? What were you thinking? They're like, I wasn't thinking. You're like, I know. And you're like, that's artificial intelligence. No, it's not. That's just no intelligence, okay? Artificial intelligence is different. It actually is machines that are imitating intelligent behavior. That's what artificial intelligence is. And we see this all over the place. For instance, recently a group called OpenAI, they actually have created an engine that writes news stories. All you have to do is feed it a set of keywords, and it will come back with 7-paragraph news story complete with quotes from government officials. It's amazing. Now, the caveat there is it doesn't actually have to be true. It just needs to sound like it's true, right? Which makes it a perfect tool for CNN. Oh, sorry. Okay, bad Jerry. Okay. But AI is all over the place. Now, a famous technologist recently said, I'm convinced that artificial intelligence is our primary directive. It's bigger than automation, IoT, big data, or just about anything else. It is a mechanism that drives exponential value from all other technologies. The person who said that was me. I said it just last night in my office. But I really believe this. AI is the technology that can elevate other technologies in and of themselves, can give you value, but now you can get even more value, sometimes exponentially so, by applying artificial intelligence to it. And we'll talk about an example of that in a minute. Artificial intelligence can actually be broken down into 2 components, automation and machine learning. And I'm simplifying things a little bit for the sake of this talk, but essentially it's those 2 components. Now we know what automation is, right? It's reliably repeating a process without human intervention. That's what automation is. But what is machine learning exactly? Machine learning. Machine learning is computer algorithms that are learned through experience automatically. All right? Computer algorithms that are learning automatically through experience. Now, what exactly are they learning? Are they learning, Picasso or the Pythagorean's theorem? What are they learning? No, they're learning to recognize patterns. That's what they're learning. Like, why is that important? Why is it important to recognize patterns? Sir, what's your name? Paul, what's that? Paul. Okay. So let's say Paul's going to go to Google and he's going to type in a search. And he wants to search on cat pictures because I know Paul, he just searches on wholesome family things. So he searches on cat pictures, right? How did Google know to return the cat pictures? How did it know that? How does it know the difference between a cat picture and a dog picture and a raccoon and Trump's hair and a giraffe? How does it know the difference between all those things, right? Well, it knows the difference. Yes?
It's because my password is I love cats 1, 2, 3.
Okay, exactly. He said it's because my password is I love cats 1, 2, 3. How did Google know what a cat picture is, right? It knows the difference because it learned that through experience. So let's bring this back to maybe an example that's a little bit closer to home. Let's say you have a shop floor system that records downtime. It could be an MES system or an IoT system, or maybe spreadsheets. And you've been collecting this data for a long time, all right? You've got 5 years of spreadsheets. After every shift, you fill out a spreadsheet that says, okay, here's the production we had, and here's the downtime. Now you get a new boss. The new boss says, hey, you've got 5 years of spreadsheets. I want to know why we have downtime, when and how, and what are the conditions under which we have downtime. And so you're tasked with figuring that out. So what do? You're like, okay, I could hire a couple programmers, and they might write some code like, if this, then that, but they're gonna probably introduce some bias on what they think causes downtime into their code. What if I hired some interns to analyze all these spreadsheets? Well, 5 years of spreadsheets, 1 per shift, that's almost 6,000 spreadsheets. How many interns are you going to hire to analyze all those spreadsheets? And then how are they all going to communicate at once so they all know what everyone else is knowing at the same time? That's the problem, right? And could they repeat that? Even if they figured it out, could they repeat it successfully? And this is what the combination of automation and machine learning gets you. It gets you 100,000 interns. It gets you 1 million interns dirt cheap. And they're all working together like the Borg in Star Trek, all right? That's what machine learning gets you. It's all these interns cheap. So now we can plow through 5, 10, 15 years of data and analyze it like that. So instead of wondering about important things like what is a cat, we can now say, what are some patterns in my downtime? What are some patterns in our injury records? What are some patterns in our defects that we would have never seen before because we never had the capacity or the ability to encapsulate and grasp all of that information at once? That's why machine learning is so important, and that's why it's crucial and critical to what's happening in manufacturing today. And the cool thing is, you can do this right now. This is cake for AI right now, for machine learning. In fact, this is one of the ways that I recommend people get started in Industry 4.0. If you have a set of data that you trust, you can get a really cheap Azure or AWS subscription. Sometimes you can get it for free. Just upload that data. They have really quality, powerful, easy-to-use machine learning tools, and just start playing with your data and see what insight you get. No risk to your current process. It doesn't really require a huge budget change. It just helps you get on board using some really cutting-edge technology. And the cool thing is AI has already moved on. We're already tackling things like vision, cognitive understanding, natural language communication, all those things that actually differentiate us, getting closer and closer to having a hard time noticing the difference between us and actual AI. What's the second one? Additive manufacturing, all right? Additive manufacturing, basically using 3D printers to print stuff, right? Now, there are some technical differences between the terms additive manufacturing and 3D printing. We're really not going to go into that now. Those nuances are not important for the sake of this talk. Sometimes people use them interchangeably, so forgive me if I do during this talk, because for our purposes, they are basically the same. So about 5 years ago, my wife surprised me and the kids, and she took us to a drone race. Have you ever been to a drone race? Anyone ever been to one of these? This is fascinating. It's, just like you see here, it's a drone race. You got these 10 or 15 drones out in the field, and they have a start and finish line and barriers that they have to go under and around, and these drones, they're just all flying, right? But here's the interesting thing. The pilots of these drones, they're not watching the drones. Do you know why? There's a camera on the front of that drone. And so they are watching what that drone sees through goggles. So what you actually have is a bunch of pilots that are not even looking at the race. It's the most surreal thing you've ever seen. They're all over here with their heads down, and the drones are all going all over here. It's the coolest thing. I really recommend you go see it. But during the race, one of the pilots tried to get under one of the obstacles, and he went too low, and he hit the ground, and that drone just boom, crashed. It just end over, parts went flying, and I was like, oh, that's so cool, because it wasn't my drone. And so he went and he picked up all the pieces, and he came back and he was right next to me, and then I felt bad, and I was like, oh my goodness, I can't imagine you've got to order all those parts and the expense and the time to get those all in, and that's going to put you out of commission for a while. And he looked at me with a frown and he said, no, I'm just going to go home and reprint them. It blew my mind. You're going to reprint them? Oh my gosh, it hit me right there. This is a game changer. It cuts everyone out. I just go home and reprint them. Now apply that to the industrial application. Now, additive manufacturing has been around for a long time. It's another technology that's been around for quite a while, since the 80s or 90s, right? But we had some technological breakthroughs in the last 8, 9, 10 years, combined with some patents that have expired that have allowed players to get involved in this space that they hadn't before. And then, along with that, anytime technology starts to get more and more popular, then it goes lower and lower. And now we actually have consumer-based, sub-$1,000, sub-$500 3D printers that hobbyists can use. So when you look at this whole space here, it's just poised for explosion. And we can print with all sorts of materials. We can print with plastic, polymers, wax, titanium, steel, and that leads to a whole host of applications that we can do with this. So what are some of the things that we can do with this? One of the coolest things is we combine generative design with functional prototyping. Okay, Jerry, that's a lot of big words. What is generative design? You probably know what functional prototyping is, but what is generative design? Generative design is a new process where an engineer will input design goals into their design software, into their CAD-type software, but along with those goals, they'll give it some parameters, some restrictions. Okay, I can only use these types of fabrication methods. I have this material available to me, and here's my cost barriers, all right? Here's my budget. And they'll feed that into this specialized software, and it will start iterating through all the permutations and designs. It will generate alternatives. And it's interesting because the results are very organic. In fact, right here, this is, oops, sorry, wrong way. This is actually the result of a generative design process. Now look at this. All these parts right here, they do the same thing. They can actually handle the same structural load. But that part on the right, it's much cheaper to make because it uses much less material. But you're like, what the heck is that? It looks like some alien Picasso vomited that on Mars. How do I fabricate that? There's no fabrication process I know of that can make that. Well, 3D printing can. And now you start to see, oh my goodness. I can use generative design to actually get these designs quicker, iterating through all those permutations, And then I have a machine that can actually print that. How cool is that? So now I'm taking, and here's the cool thing. Computers have been, we've been using computers for iteration for forever. So the big deal here is in this generative software, we're actually applying machine learning. So now the software is saying, okay, I know with these kind of parameters, I know what you want. I have learned what actually works over time. So the next time you start that generative process and that generative design, it actually starts closer to the end game because it's learned these things don't matter. These things do. And the next time, and the next time, and the next time it gets closer and closer. So you are shrinking that design phase, shrinking it drastically. And then you've already shrunk the prototype phase because you don't have to fabricate it, you just print it. So that whole space is shrinking dramatically. So that whole process of design and prototype is going from years and months to weeks, even days. It's phenomenal what's happening there. By the way, architects have been using generative design for quite some time. If you just go to Google and you search on generative design architecture, you'll see some really cool designs that look a lot like that. What's another advantage of additive printing? We are using materials now in our printing that is so strong, we can actually put them in our end products. This is the GE LEAP 1A engine. It's used in the Boeing 737 MAX and the Airbus 320. This engine has 19 fuel nozzles that are printed. Think about that for a minute. That's amazing. I'm not a big flyer. I'm worried about the day when I sit down in a jet and the guy next to me says, yeah, that engine was printed on my nephew's 3D printer. I'm like, oh my gosh, right? But apparently it works. It's amazing. 12,000 of those engines are being produced right now. This is one of my favorites right here. Most engineers are hard-coded to keep things simple. Why? Because complexity has cost. And here's why. Most fabrication methods are subtractive. You start with a block of steel or a block of material, and then you take material away until you get to what you want. So the more complex the part, the more sophisticated your process and your tooling has to be to get there. And that's expensive. That's why this is an impeller, and it's really hard to machine. But 3D printing is not subtractive, it is what? Additive. Very good, you're paying attention. It's additive. I only have to add. So 3D printing that part is a piece of cake. Complexity is completely free when it comes to additive printing.
But you have a limitation on materials.
A limitation on materials?
I mean, if I want to use something for mechanical strength or, a part which is made out of cast iron, how could you do that in 3D printing?
Yeah, you can. You can print metal.
Down the road at Wayne State, they're 3D printing diamond.
Yeah. It's amazing how far the technology has come, printing steel and titanium.
Even the tolerances and everything is maintained in 3D printing?
Even the what?
The tolerances.
The tolerances, yes. Yep. I mean, I can guarantee you that GE wouldn't be putting
Yeah, I was surprised.
that in place if it couldn't maintain the tolerances. The airline industry is one of the most strict. What's that?
That was on a Max, you said.
Yeah, but it has nothing to do with them all crashing. All right, that's something completely different. That wasn't the problem. I almost didn't say the MAX, the Boeing 737. It is fascinating what's happening here. All right. Here's another huge, and the last one I'll talk about, additive printing. Personalized manufacturing. We now can take the consumer and drop them right into the middle of the design process. So just by sheer chance, a couple days ago, I was sitting on the couch watching TV, and I love Big Bang Theory, and it came on, and Raj and Howard had spent $5,000 and bought a 3D printer. And so they were playing around with this 3D printer, and guess what it was that they printed? What's the first thing that they printed? They did what any self-respecting nerd would do, and they printed an action figure of themselves, right? And I thought to myself, well, is that a viable business model? What if I opened a business that printed Jerry Foster action figures, right? And I could do that, and I would probably, I would sell like maybe 3, my mom and my dad and my wife, or 2. I would sell 2. But here's the thing, it is a viable practice. It wouldn't with traditional printing methods because I couldn't cover my upfront costs. But now I can one-off things because the cost is negligible from one to the other. I could ask all of you to send me a photograph and put that into specialized software and print an action figure of you without much additional cost or complexity. So I'm now introducing personalization into the manufacturing process, which is amazing. The whole thing is getting tighter and tighter and closer. Okay, that's Big Bang Theory, Jerry. Tell me about the real world. What if I could 3D print prosthetics? This is a prosthetic leg that's 3D printed. And here's the cool thing about this. You can print it quickly. It's not this ugly, robotic, big mechanical prosthetic that we're used to seeing. This is refined, this is cool looking, and it's actually printed to the exact specifications that the patient needs based on their injury or the issue that they're having. To the millimeter. You know what that means from a comfort level? And it looks cool. They're like, look at this, man. And here's the interesting, I didn't follow up on this, but look at that design. I suspect that came from generative design. That looks like that thing that we looked at a few slides ago. I suspect it was built with generative design. This is Star Trek stuff, people. And then even cooler, you can now print, you probably can't see it, but they can actually print designs on their prosthetics. Talk about so you can not only do you get a comfortable fit now, you can personalize it. How cool is that? And we're just scratching the surface here, guys. I think additive manufacturing is just ready to blow up. Blow up the industry, blow up manufacturing. All right, third technology. Blockchain. Blockchain. Blockchain is quite the technology, right? It's been been in the news. There's been a lot of talk about blockchain. And here's what's interesting about blockchain. Basically, blockchain is a distributed digital ledger. It's a transaction. It's a historical transaction. But here's the interesting thing. It is built on peer-to-peer networking, which is yet another technology that is what? 15 years old. It is built on the back of peer-to-peer networking. And here's the thing about peer-to-peer networking. What you have is a number of nodes that are connected, that share resources, that don't have a centralized administrative system. All right? They're all sharing. There's nothing central here. And so you might remember some of these programs that initially used peer-to-peer networking. Remember Napster? Remember when MP3s came out in music files, and you used Napster to share those MP3s? And then a program came out called BitTorrent, where you could even share more expensive things like movies. And then you're thinking, okay, if you know anything about your history, you're like, well, Jerry, those products were actually used by a lot of shady characters to proliferate illegal content and piracy. Well, why do you think that was? Because they're hard to shut down, they're secure, they're accessible by everyone, they're immutable, they're historical. That sounds like some things I like to have for my enterprise content. So some enterprising individual says, you know what, I think I would like to use that for more enterprise type stuff. And so they applied some technology on top of peer-to-peer networking and came up with Bitcoin. So what Bitcoin basically is we record a financial transaction between two individuals in a block, or basically a piece of data. And that financial transaction, when authorized, is then connected to the previous transaction, which was connected to the previous transaction, and so on and so forth. Pretty soon we have a chain of blocks, or blockchain, right? And that entire blockchain is then put on all of those nodes in that peer-to-peer networking type scenario. And that's how we have Bitcoin, and that's why it's so powerful. Now imagine taking that in the context of the supply chain. Imagine if I wanted to follow a piece of iron from the minute it came out of the ground to the vehicle it was put in. Would that not be cool? Would I not want to know what happened every step of the way to that piece of iron ore? It may have been brought out of the ground in China and shipped to the United States in a boat, and then it went to various processors and suppliers and ended up at an OEM and then put in a car. I'd love to see all of that. Timing, what happened to it, how long it was at each spot. But here's the thing. The frustrating thing about the supply chain right now is it's full of friction. Everyone has their own standards. There's too many go-betweens. There's back and forth. There's lawyers. And these things that should be simple between suppliers in the supply chain are complex, multi-step processes that get in the way of any historical transaction. And then you introduce the global nature of the supply chain. You have national interests and government interests and rivalries and all these things that prevent us from getting to what we need, a consistent historical record on the supply chain. And this is where blockchain has the potential to blow things away, to revolutionize that. And here's the reason. Because even if all these components in the supply chain don't trust each other, they all trust the blockchain. And that's the key. I trust the blockchain. I trust that it's secure, immutable, historical. And when everyone trusts the blockchain, then I can make progress. Then I can actually start to implement this. And I have a distributed ledger that's accessible by all members, giving us the ultimate in traceability. It's got huge potential. Now, there's also some challenges with blockchain, all right? Because of all the three technologies talked about, it's probably the one that's the farthest away from actually becoming mainstream. One of the issues is that everyone has to be involved. To whatever extent suppliers in the supply chain don't get involved in blockchain, that's the extent to which blockchain effectiveness is diminished. So we need every player involved. This is why it's important that the 800-pound gorillas in each space actually start requiring their suppliers and their supply chain to get involved with blockchain. You already see this if you're following the news. Walmart has already started this, requiring their suppliers to use blockchain. The potential here is enormous. But there's a lot of hype, right? There's still a lot of hype, and so we're kind of behind the hype curve on blockchain, and there's lots of debate. Is it actually going to give an ROI based on all the complexity and all of the effort to get it in place? Even at my work, we have huge discussions on the viability of blockchain because we're geeks, and that's what we do in our lunch hour. We argue about the benefits of blockchain. There's a lot of hype here. Can it cover that hype? It's a new technology that is, to be honest, it's very complex. There's a lot involved in completely understanding how blockchain actually works. Cryptography, encryption, all sorts of stuff that you have to be an expert on to really make this work. And there's a lack of expertise in the market on blockchain. It's a barrier. Loss of privacy. Remember, the whole reason we want blockchain is to expose all those transactions across the entire supply chain. That means you get to see everything. Are you okay with that? Are you okay with what happens to that part as it goes through your plant being exposed to everyone in the supply chain? I don't know, maybe not. I thought I liked blockchain until that one. Now I'm not sure. So that's something we have to overcome. And then, of course, the last one, who do I yell at? Who do I yell at when something goes wrong? Remember, the whole thing is based on the fact that there's no centralized system to control it. So if something doesn't work, where do I go? You're looking at me like, okay, where do you go? I'm like, I don't know. That's the problem. That's why it's a barrier. I have no idea. So those are the three technologies: additive manufacturing, AI, and blockchain. I think are really going to have a huge difference in Industry 4.0 and technologies as we go forward. So my call to action for you, I just want to encourage you to start someplace, right? And remember, think of how we started this presentation. You don't have to jump over a cliff into all these technologies that you're not aware of. They've all been around the block. What are you doing right now in your business that could benefit from bringing on board one or two technologies? And I love this picture, especially since I ride a motorcycle. I love seeing that. Man, it's just like, whoo, it's going to be awesome, right? We're in the middle of some incredible potential right now inside Industry 4.0, and you have the ability and the capability to be part of incredible change at your organization, all right? So I want to encourage you, you're not behind, but I also want to instill a sense of urgency. If you wait too much longer, you will be behind. So you need to start getting involved right now. And just like anything that's worth doing, it can be hard, and it's usually that first step that's the hardest, right? Getting going, but once you get going and get things rolling, it becomes a little easier and a little easier, all right? So that's actually my take. I think, I'm right on time. We're about 2 minutes early, so I guess I could take a couple questions if you have them. Don't guarantee that I can answer them, but anybody have any questions? All right, I'm not going to belabor the point. If you want to ask me any questions or send me any correspondence, you can look me up on LinkedIn, just Jerry Foster at Plex. I wouldn't send me an email because I'm a very aggressive spam catcher. You'll probably never hear from you, but I do follow all my LinkedIn messages, so if you want to contact me, that would be the way to go. All right? Thanks so much, you guys. Have a good rest of the day.